here in one question. 2.8. 2.8 is the last section. Quite interesting one from the application point of view. So what is going to be related? Okay, related rates or the related rates problems. See, when we talk about the rate, you mean derivative. So your function is what? Your function is y equal to the f of x. X is a variable, okay, and y is a function of x. If you find the derivative of the function, f prime or y prime is what? Is the rate of change. Is the rate of change of the value of the function with respect to the x. That's why we say y prime equal to the f prime of x. But the situation for these problems are going to be, you see, in everyday life, these x and the y are going to be a function of a third variable. That third variable is the time. You see, when we talk about the rate of the cost, okay, revenue, or the rates of the growth, it depends on the time that you're going to get these type of ideas. So these type of problems are going to be called related rates problems. It's easy problem. It's very standard, but it's very important to understand it. So I'm going to give a description what is this problem is, then we get the examples that we are going to consider. Okay, so let me just recall what it is, and let me know any part of this one if you feel that we need to explain it for you, because there is a final part. It's a chain rule again. Okay, so I'm just give you the definition first. So recall that, see, we talk about unemployment rate. Okay, so when you talk about unemployment rate, you are going to talk about that rate at a specific time. You see, each Friday they give you unemployment rate. So that's a rate of change at a specific time. This is the type of problem that we have. Recall that if the function, okay, if the function y equal to the f of x, like y equal to the x squared, y equal to x cubed minus 2x plus 1, is differentiable. Means if we can find the derivative. If this function is going to be differentiable, then as usual, f prime of x, you see f prime of x is what? Is the rate of change. Is going to be the rate of change. Remember, rate of change or speed, velocity. Rate of change of y, of the value of the y, okay, with respect to I'm going to use this expression quite a lot, so I'm going to abbreviate it with respect to. Okay, so this is going to be f prime of x is the rate of change of y with respect, okay, to the variable x, to the variable x. Okay, that's going to be one. Okay, you know that in particular case it's going to be if we get a moving object. Okay, just a reminder, it is nice to compare it here from the physics problems. Okay, in particular, if that f of x, if f of x is going to be what? Is the position of the moving object. You derive on freeway. Okay, is the position of a moving object. So the situation is going to be what? Then you know that f prime of x is what? Is the velocity. Is the velocity. Velocity of what? Of the moving object, okay, at x. So you may call it the rate of change, or you may call it velocity. Both of them are going to be the same thing. Now, so what is going to be the question? So that's all we've been doing so far. Okay, function is a function of x. We differentiate respect to the x. Now bring the third variables. What's the third variable? Say, oh, if, you see, if the variables, x and y that we've been using, okay, x and y are functions, are going to be functions of a third variable, okay, of a third variable. That variable is going to be time t of the third variable time t. Okay, time t. Then what we're going to have, look at this one. Then you are not going to have x. Your x is a new function. X is a function of t, x of t. Okay, and what is going to be y? And y is not going to be just y, it's going to be y of t. You see, this is the situation we're going to have. So it's like, you know, that when we say x and y, you see x and y is what? X and y is a point. Look at this one. Look at this one. You see, suppose you have your path is going to be you have a circle here. You see, if you get a circle here, this is a circle. So at any point, you see, if you pick one point here, if you pick one point here, you see, at a specific time, if you want to tell us your position, say, oh, my position is going to be what? Is going to be x comma y. So this is going to be the coordinate of your position, if you like. Of course, you are going to be in three-dimensional, so it's going to be x, y, z, and the earth is spherical. But if you just pick these numbers, you see x equal to 2, y equal to 3. This is what you'll be doing. You say, oh, this coordinate of this point is 2 and 3. But at different time, you are going to be at different position. You see, if you walk, okay, if you run, so a couple of minutes later, you may be here. A couple of minutes later, you're going to be here. So you're going to be here, going to be here, be here. So if you want to find out exactly where you are, what we need is, you need to have your position in terms of the t. So when you move, but you move along the circle, okay, and we have your information. But at different time, you are at different positions. So in this case, your function x is going to be a function of t, and the y would be a function of t. If we want to know where are you after 2 seconds, 2 minutes, so we go to these two equations, we replace the t by 2 minutes. Then we find out where you are. Okay, so that's going to be the kind of new format that we're going to have. Okay, any question? No. Now we have a new function, but this is a function of t. So if these functions are going to be differentiable with respect to the t, so you see, suppose x is equal to 2 t squared minus 2t, and y equal to the t cubed. So now we can differentiate it, but we can find the derivative with respect to the t here, okay? So in this case, we have a new situation. In this, okay, in this case, so what we have, x prime of t, you see, derivative with respect to the t. X prime of t is going to be called, it's called what? It's called the rate of t. It's called the rate of change, or just the rate. The rate of change. The rate of change of what? Rate of change of x with respect to the, okay, to the variable t, the time t, variable t. Okay, and we write, you see, we write this x prime of t because we want to identify that this is dependent on t. You may call it x prime of t. but we write it down as a dx dt. Okay, so dx dt, we read it as, we say this is the rate of x respect to the t. It's derivative. Okay, it's derivative, so it's going to be rate of change. Okay, and similarly, okay, and similarly, we do the same thing. Similarly, okay, similarly, we are going to have a y prime of t is going to be the rate of change. Okay, the rate of change. Rate of change of what? Of y. Of y with respect to the time t. And we write what? We write y prime of t is equal to dy dt. Okay, so dx dt is going to be the rate of the x, dy dt is going to be rate of the y. It's going to be your speed, your velocity. You see, when you go around the circle over here, so your x coordinate, you see, going to the right, to the left, your y coordinate going up and down. So you may have a speed when you go to the right and the left, and you are going to have a velocity or the rate when you go up and down. So these are how you're going to relate them, okay, related together. Okay, so what we have so far? So far we are going to have original function y equal to the f of x. So this function is differentiable, so we get y prime equal to the, let me just remind you what we are going to have, because we already say, oh, note that x and y are related to each other, are related by, okay, by the equation. Okay, they are related to each other by this equation. Okay, y equal to the f of x. So if you substitute, if you change, you change the x into the x of t and the y equal to the y of t. So the situation that we're going to have is a new situation, you see. You got this one, that would be y of t. And this is going to be f of x of t, you see. Now we bring the chain rule, because this is a composition of two functions. You see, a composition of two functions. So if you differentiate it, so by chain rule, so this is what you're going to have. By the chain rule, you differentiate it. See, we get y prime of t. Chain rule, remember, is f prime of t. Derivative, remember, outside function times the inside function, x prime of t. But if you change it to the notion of the rates, you have something interesting. You see, this y prime of t would be dy dt. This is the rate of the y respect to the t, the time. This would be equal to f prime is what? F prime is y prime. Remember, this is the rate of the y, respect to the rate of the x, y prime. What is this? This is dx dt. You see this equation? We talk about three different rates. Now we connect them together. This equation is called related rates equation. So in this type of problems, the situation will be created. Then you have to use this formula. dx dt, rate of the x respect to the t, or dy dt. One of these would be missing. The other one would be, this is just a derivative. You see, whatever function you have, you can find the derivative, you see. But dx dt, rate of the x respect to the t, and the rate of the y respect to the t. These two are going to be your problems. One of them would be given, the other one would be, you are going to ask for it. Okay, so that's the idea of the problem. Now we're going to do it to get what's going on. So it's nothing new. It's a chain rule. It's a chain rule, but we put it into the format that's going to be quite important. Okay, to get these numbers. So it depends what type of function do you have. You have a growth function, decay function, okay, price, cost function, revenue function. So for all of them, you can apply this nice format of the chain rule to get the numbers done. Okay, any question? It's all algebra. Let's put it into the action to see what does it mean. In fact, okay, it's nothing new. This is going to be the formula, but the expression that we use the expression of the rate or just the velocity to get these numbers. Let's see how we're going to handle this type of problem for us. There are two types of problems. The first one is abstract. You don't care. This is a formula. A function would be given to you, substitute to get the result. That's type 1. The type 2 that we are interested in is the everyday life problems. When I teach calculus 1, 2, 3, I give them 6 different situations in everyday life that we usually use it. But in your case, I'm going to give you 2 because you are going to have social science or just the business most of the time. Okay, but you're not going to miss anything. I give you one of those 6 types so you get to understand it. Okay, so almost we are going to have 3 problems to discuss. Let's give you the abstract one first, the machine first. Okay, the machine, then the everyday life. Let me just tell you how we're going to handle these type of problems. The first one is just a function would be given, but you'll be told that, let me just describe it. So you don't need any background to get these problems really. As soon as I write the first one, you know how to design it. Okay, so what's the abstract one? Exactly as I told you. They are going to tell you that, suppose, that's the first one. You have quite a lot in your assignment of these. Suppose x and y are differentiable. Functions of time t. You see, they have to tell you, otherwise you just treat it as a normal one. As soon as you see this, you'll find out this is a related rate problems. It's not ordinary x and y because they are a function of the time. So suppose x and y are differentiable functions of the time t that are related. They have to give you an equation that are related to each other by one equation. By the equation, easy equation, y equal to the x cubed. If they don't tell you this, if they just give you y equal to the x cubed, this is ordinary function. It's not a related problems. But when they argue that this is a x and the y are a function of t, then you realize that there is a third variable involved. So what they ask, they give you one of these rates respect to the time, as I told you, and they ask for the other one. So in this problem, they ask you find dy dt, means the rate of the y respect to the time, which is the velocity of the y, when x is equal to 2 and the rate of the x dx dt is equal to 4. You see, this situation means you know that the rate of the x respect to the t is 4. You know that many of the related rates. So this 4 is positive. So this means the value of the x would be increased. You know that would be increased by what? It's going to be by 4 per units if you have per hour, whatever you have. So you want to know against this action, against this increase in the value of the x, what would happen to the y? So how are we going to compare the ratio of the rates together? So that's the idea of this problem. So in order to solve this problem, and this is the way you're going to do it on the test for us, you have to design this problem. This problem would include the following. You see, solution. You have to do exactly the one on the test to get the full credit. Designing it is going to be 40% of the grade. So how are we going to design? You see, we have two rates always, dx dt, dy dt. One of them would be given. We call it given rate. So for each problem, you have to identify what is the given rate. Is it x or is it y? In this case, it's x. So you identify it. So my given rate is what? Is dx dt. This is my given rate. And this is equal to the 4. Most of the time would have a special unit, but you don't have it. You write it down. Any question? So you identify the given rates. There is going to be one that you are going to find it for us. That's the unknown one. So what is your unknown? Unknown. Okay, what's going to be unknown rate? So in this case, it's clear. The given one is dx dt and the unknown one is dy dt. So dy dt is going to be the unknown one. It's not known. But they give you some information as what level, at what time you want to get it. You want to find it when x is equal to 2. So we want to find it when x equal to 2. So this is going to be the unknown. Any question? So we read the problem, identify these two. Next important part is, what is a relationship between x and the y? You need an equation because you want to differentiate. That equation is going to be called related equation. Related equation. How these things are going to be related to each other? It's given to you. Y equal to, okay, that would be y equal to the x cubed. That is how you design this problem. Any question? The given rate, which is read the problem, you will find out. As soon as you find the given one, you see the unknown one is going to be dy dt because they ask for it. It's going to be always with some information at what level, okay, you want to find it.
Excuse me, can you explain how you got the 4 again?
You see, given rate, you read the problem, you say,
Mm-hmm.
you ask for find dy dt when x is 2 and dx dt is 4.
Oh, so those are just directly given.
Yeah.
Oh, okay.
Okay, so that's a given one and that's the unknown because you want to find it.
Yes, okay, thank you.
Now, you need an equation to be able to differentiate. That equation is this one. Those 5 problems that I talk about it, we usually find the equation number 7. But in your case are going to be just, you may have to find the revenue function or the profit function, but the equations most of the time would be given. Okay, so that's the design of the problem. What's next? You differentiate this equation. But you differentiate with respect to the t. Respect to the t means this formula. You see? So dy dt, you are not going to write y prime because it's quite something different. You write dy dt, you differentiate the equation with respect to the x. Whatever it is, you multiply by the rate of the x. Dx dt is a chain rule. Okay, there is a function inside. There is a t inside these. See, there is a t inside these because these are a function of t. So what you are going to do is, you are going to explain it. Differentiate this equation, y equal to the x cubed, but with respect to time t. Time t means the derivative of the y is not y prime. It's dy dt. Okay, we write dy dt just to make sure that we differentiate respect to the t. Then we go to the second part. Apply the rule, the power rule. The power rule is what? Is going to be 3x squared. But you have to multiply by the rate of the x because you differentiate respect to the t. It's like u prime that we did it before. So the rate of the x would be dx dt. See? So you differentiate whatever is given to you just using the power rule. But make sure you multiply by the u prime, multiply by the rate of the x. This is going to be called, you see, this is, as we did it before, related rates equation. You see, the given equation is just a given equation. When you differentiate it, it's going to be related rate equations. Now you are ready to get your result. So put the known here. So what do you have? You have the dx dt. You see, you have the dx dt is equal to 4. dy dt is the missing one. But you wanted at what? At x equal to 2. Substitute. If you substitute here, so dy dt is the missing one. Okay, dy dt is the missing one. So it's going to be equal to the 3x squared, 3 times your x is 2 squared. Times dx dt. Dx dt is 4 times 4. That's it. Simplify. 2 squared would be 4, so that's going to be 3 times. 3 times. You do the power first. So that's it. 3 times 4, 12. 12 times 4, 48. So dy dt is going to be equal to what? Is equal to the 48. If there is any unit, you are going to use it. But in this case, no unit was given to you. That's it. See, so this means if x is going to be, you see, this is x is dx dt equal to the 4, that's the rate of change. It's positive. So this means if the value of the x increases at the rate of the 4 units per hour, if you like, then the rate of the y would increase at the rate of 48 units per hour. Okay, this is how you compare these two together. And so if you do a little bit more here, so you get much more here. So it depends on whatever problems you have, then you can make a decision and just go for it. Any question? So it's nothing complicated because your equations are just powers of x. So you have to nicely design it, get the information, what's the known, what's the unknown. Okay, and then easy derivative. Don't use y prime, you are out. Because y prime is where you use the function of x, the rate of the y respect to the x. But they are a function of t, just use dy dt. It's like y prime, dy dt. You use the power rule as usual, 3x squared, but you have to multiply by the rate of what variable is here. So dx dt is like u prime. Why? Because the t is inside here. Okay, the time is inside. They are not alone. Okay, that's why you take these rates. Now you substitute and you can find an answer and then you're done. Any question? That's abstract. Okay, but we like everyday life. So I'm going to give you two examples. The first one, I just give you this one just to understand the topics. But the second one is the example from business that we give you that second one. So this first one and the second one is part of your job. But I'm going to describe one. This second one is very important one, It's a very famous problem of the rate of change, but you understand it, then we go to the main one, okay? Any question? Remember, given base, unknown equation. You get the equation differentiated. Y dy dt. X cubed 3x squared times the rate of the x, because the t is there. Okay, to get these numbers. Okay, let's see the first application problems, everyday life. This first one is very, very popular. In any calculus book, they talk about it. We call it a sphere problem or the balloon problem. Okay, so the first example from everyday life, to get a better idea of the problem, we call it a sphere. Okay, a sphere problem or the balloon problem. What's a sphere problem? Suppose you have a balloon. Okay, so what do? You have to blow in it to expand it. Okay, so this is it, a spherical. Suppose you have a spherical, okay, a spherical balloon. The spherical balloon is expanded, or expanding, okay. So we want to make it big, that's one. Now, given that when you do this job, the radius of the sphere or the balloon, okay, the radius is increasing, getting bigger and bigger, increasing at the rate of 2 inches, rates of 2 inches per minute. Okay, so the radius is increasing at what rate? At the rate of 2 inches per minute. That's a given rate. So they want at what rate? At what? Okay, at what rate is the volume? Okay, is the volume of the sphere is increasing, is going to be increasing when the radius has at this time, when the radius is 5 inches. It's very nice problem, give us a better understanding of the problem that we're going to have. Okay, when you're expanding a balloon, a spherical balloon, there are two quantities that's going to be changed. The radius of the sphere, okay, and the volume of the volume of the sphere. So we want to compare these two together to see what's going to be the result. Okay, so we realize that it's going to be related rate problems because they talk about the rate. So what you're not going to do, you have to design it. Remember, what's going to be the design solution? So for the solution, this is how we are going to design it. Remember, you have to tell us what is the given rate. What is the known one, if you like, given rate? You read the problem carefully and tell you, given that the radius is increasing at the rate of 2 inches per minute. So the given rate is the rate of the radius. The radius is denoted by r, so the rate of the radius would be dr dt. Okay, dr dt is going to be the rate of the rate of the radius is given to is 2 inches, so it's going to be equal to the 2. It is a unit. The unit is what? It's going to be inches. Okay, it's going to be inches per. Okay, inches per minute. So that's the given rate. Any question? What's the unknown? At what rate the volume is increasing? So the unknown. Okay, what's going to be the unknown rate? Unknown rate is going to be the rate of the volume. Volume is going to be denoted by V So it's going to be dv dt. So this is missing. Any extra information? Yes. At what rate is the volume increasing? When the radius is 5 inches. Then they have to give you some level, okay? When r, the radius, is going to be equal to the 5 inches. Any question? So we read it, you know, that's it. The problem would guide us through this to finding these two quantities. So the variables that you're going to use are going to be radius and the volume of the sphere. So you need an equation, okay, to be able to go for it. So the equation should be between what? Would be between the volume of the sphere. This is the one that, you know, if it was going to be, which is not going to be. If it's going to be on the test, we give you that formula, okay, but related equation, what equation do you have to be able to differentiate it? Volume of the sphere. The volume of the sphere is a famous formula. It's going to be 4/3. Okay, 4/3 pi times r cubed. So this is the volume. Okay, this is going to be the volume, okay, of a sphere. So now we give you this formula if we're supposed to. They usually talk about the circle or the sphere. Okay, so there you are. So you have the given rate dr dt is equal to 2. Unknown rate is the volume dv dt. You need an equation to differentiate it. The equation is just the volume. Okay, 4/3 pi is a number. So you have r cube, like the x cube that we did. So what we're going to do is you differentiate this one with respect to the t to get the related rate equation, and you substitute and then you tell. Okay, so as usual, I just explain again. You differentiate. Okay, this is it. Differentiate this equation. I just repeat it. 4/3. Okay, 4/3 pi r cube. You emphasize with respect to the time t. Now we're going to differentiate. You see, the derivative of the v is the derivative of the v respect to the t, as I told you. It's not v prime. So it's going to be dv dt. Whatever it is, rate. Rate of the y is d by dt. Okay, speed or the velocity. Rate of the v would be dv dt. On the other side, you just apply the power rule to whatever it is. 4/3 pi is a number. Use the power rule for r cubed. It's going to be what? It's going to be 3r squared. But remember, you have to multiply by the rate of the radius, whatever it is. If it is x, dx dt. If it's r, dr dt. If it's a p, dp dt. So you multiply by dr dt. Okay, because you're just using the chain rule or implicit differentiation as you did it before. So it's always multiplied by the rate, r prime in this case, v prime. Okay, the rate of the given variables. You simplify it, and you substitute. You see 3 and 3 we cancel out. So that gives you dv dt. Okay, so that gives you dv dt equal to what? Is equal to the 4 pi r squared. 4 pi r squared, but it's multiplying by dr dt. You see, this is related rate equation. So the first one is just the equation, but this is going to be related, okay, rates equation. So you connect them together. Now bring the information and substitute. See what you have. The known one is dr dt. Okay, so the dr dt What is the DRDT? Your DRDT is 2. DVDT is missing, the unknown. When you want it when R is equal to 5. Substitute in this equation. Okay, so d by dt is the missing one. dvdt is the missing one. Is equal to the 4 pi. R square, R is 5. So the R square would be 5 squared times the dRdt. dRdt is 2. Okay, R is given to is equal to the 5, so that gives 5 squared. Okay, dRdt is given is equal to 2. Simplify, do that. 5 squared would do 25. So it's going to be 4 pi. Okay, it's going to be 4 pi. 5 squared 25 times it by 2. Simplify 4 times 25 would be 200 pi. 200 pi, we accept it for the 200 pi if you leave it. Or you can check the pi, which is going to be 314. Okay, so it's going to be 200 times 3.14. So the result is going to be what? We get the dvdt is going to be equal to the, okay, you get 628. Because you have 2 decimal places, 2 zeros over here, they cancel it out. So that gives you 628. That would be the rate of the volume. But you have to give us the unit. Any suggestion? What's the unit for the volume? In this case. In the problem, you just go back to see what type of units they are going to use. You see the radius is in inches. And this is the volume. Volume is going to be, cube inch. Okay, this is it. Or inches cube. Per what? Per minutes. So you have to give us the unit that you're going to use. So the volume is going to be, it's cube because you multiply 3 times by itself. And the time is minutes because they talk about the minutes. Okay, so you have to write the unit on the test. Okay, no, it's going to be cubed because the volume, if you talk about the area, it's going to be a square, like a square feet. When talk about the volume, it's going to be cube feet, if you like. This is going to be cube, cube inches to get these numbers. Okay, any question? So that was everyday life problem, if you like. As I told you, there are quite a lot. There is one, we call it ladder problem. It would be too much for your course. If you lay in a ladder, against the wall, you can push it up or you can push it down, give you different rates. But your job is just doing one problem for us related to the cost, the revenue, profit, okay? So I'm going to give you a quick one. This is what you expect you to do it, and we ask you one of them. It's going to be easy one related to the cost, the revenue, or profit, okay? Just to get to know it because you use it in everyday life if you are measuring, business, if you like. Okay, so I quickly, because I have 10 minutes, I can give you one bit there. Revenue, it's usually all of them together, okay? So let's see, I write it down then because I have to explain. I'm going to pick one from your book. So you have in your assignment, this is section 2.8. This is the only problem that we're going to be interested in really. So this example is going to be from section 2.8 and I do the number 12. You are going to do the number 11. Okay, they are all the same. You have 13 as well. Okay, so I do the 12, but make sure you do the 11. You will see it on your test. Okay, what's the situation? The situation is they're going to describe something for you and they give you the cost function and the revenue function. Okay, so it's related to the company. Okay, just give you a brief description of the problem because we need it. we have a company that's manufacturing toys. Okay, a company that manufacturing, okay, manufacturers or manufactures the pet, okay, toys, calculates, they estimate, calculates that that its cost, okay, its cost, which is a C, and the revenue. And the revenue, all these problems are going to be the same, you know, they give you the cost and the revenue. And the revenue can be model, okay, that's mathematical modeling that you have. Okay, can be modeled by the following equation. By the equation, you see nicely, these equations are going to be that related equation that you need. Modeling by this equation. The cost equation, the C, is equal to the 75,000, okay, plus 1.05x, that's the cost, and the revenue is going to be 500x, okay, minus x squared over 25, or 125 of x squared. Now they are going to tell you that the x is, of course, the production is the number of the toys, where x is the number of okay, this is the number of toys produced, produced, okay, it's going to be produced in 1 week, okay, 1 week. So this is the opening of all these problems. Now they are going to give you a rate of the production. You see, this part is important. So production, okay, production during one particular week, one special one particular week is, that's the important part, okay, is 5,000 toys, okay, and look at this part, and is increasing, that's the rate, is increasing at a rate, okay, increasing at the rate of 250 toys per week. This is where you have to look for when you read these problems. That's where you have to give you the given page. So they ask for find the rate of change for all these three functions. Find the rate of change. Okay, find the rate of change. Usually give you one of those or two in this test, but they ask for all of them. Rate of change of the three cases: cost, revenue. All of them would be too much for one problem. Revenue and profit. And profit. You see, this is your problem, the one that you are going to use in every day. Okay, in your discipline, if you are measuring. Okay, business. So let's try, at least we do one of them and we finish it next time. Are you ready? I'm going to do the cost. I'm going to design the problem. Okay. So I take care of the first part 1. So in part 1, I want to know what is going to be given rate. given rate. Go and find out. You see, look at this one. The production, the number of the production is X. When they say about production, is talking about the X. The production is going to be, particular week is 5,000 and is increasing at the rate of 250 per week. So increasing at the rate, this is just dx dt. So dx dt is equal to what? Is equal to the 250. Is the 250 toys per, okay, that's going to be toys per week. Okay, that's what. So that's a given rate. Any question? What's the unknown? Unknown rate. Unknown rate for the part one is the cost. Rate of the cost. Cost is the dc dt. dc dt. For this one is dr dt. For this one is tp dt. The profit. So any more information? When you want it at particular week, you see one particular week, the production is 5,000. So I wanted when X, for all this problem, we have to look for these numbers, 5,000. That's it. Any question? Do you have any equation? Yes, of course. So what is a related equation? Related equation. Talking about the cost. The equation is a cost equation. The cost equation is what? C equal to 75,000 plus 1.05x. This is your equation. That's it. The equation will be very mild. Okay, this is going to be just easy equation. Any question? So it's going to be the revenue. You see, you bring the R here. dr dt r. For the profit, you have to go and find it. Remember, the profit is the difference between the cost and the revenue. So you have to find the subtraction. You subtract it, then you bring it here. So what you do, differentiate this one, respect to the t. Easy differentiation. So I just remind you, don't have to explain, but I remind you that I am going to differentiate. What? This equation. C equal to 75,000 plus 1.05x, but remind myself with